The next important topic is with respect to humidity and precipitation. That is, how exactly you get water or how exactly you get rainfall is what we will see. But you should be aware that with increasing height, temperature decreases. That is, if because of high temperature, if the air starts rising above, it cools and it forms clouds. And this process of heat making the warm air to rise is called as convectional rainfall. Please be clear, it is called as convectional rainfall. If you have a mountain and if the air rises, correct, will the moisture forms clouds here? We call it to be orographic rainfall. And then when I am talking about cold front and warm front, that is air is rising above, that is called as cyclonic rainfall. Rainfall associated with cyclones are called as cyclonic rainfall. Rainfall associated with mountains are called as orographic rainfall. Rainfall associated with the heating of the sun is called as convectional rainfall. Is that fine? So now, after looking at this, let us look into other aspects. That is, first important thing is humidity. Humidity means amount of water vapor present in the air at a particular time and place. And the moisture content is more whenever you have ocean or river or something closer by. If the moisture content is less, it will be dry. Deserts, water content will be less. Whereas near oceans, water content will be more. Almost 50% of the moisture is usually present at a height of 2000 meters or 2 kilometers. This is the reason if you have mountains, moisture content is less. And the moisture content will absorb incoming solar rays, outgoing terrestrial rays as well. So this is the reason we usually say mountains will receive more sun and it also emits more rays. We call that to be windows. Evaporation depends on aridity, temperature and velocity of the winds. If the winds are stable, evaporation is easy. If the wind is moving, evaporation is difficult. Dry air with high temperature is capable of retaining more moisture, as dry air requires more time and moisture to become saturated. For example, if you have 40% humidity and if you have to make it 50%, it will take more time. So 10% increase will take more time. But if you have 0% and to make it 30%, it will be very easy. Why? It is nothing. Dry air is easy. Stable air becomes saturated soon. Why? If it is present at one place, moisture keeps on adding. But let me take, I have 3 packets of air. You are adding moisture here. This will move and this will come. Again this will move and this will come. So because of this, every air mass will receive less. But here, entire thing will go to one air mass. That is, if it is present at one place, you can add more. If it is moving, you can add less. Now guys, amount of water which is held at 10 degrees Celsius is 100%. Now, amount of water which can be held by air at 20 degree is 52%. Amount of water air can hold at 30 degree is 28. So I call it relative humidity. That is, at a particular temperature, what is the maximum amount of moisture the air can hold is what we try to understand. Whenever absolute humidity, the total weight of moisture content per volume of air at definite temperature is called as absolute humidity. What is the meaning of it? The meaning of this is, at 10 degrees Celsius, if there is 15 grams, then I would say this is the absolute humidity. At 20 degree, if I have 30 grams, I call it to be humidity. That's it. I am not going to say anything. That is, total weight of the moisture content per volume of air at definite temperature is called as absolute humidity. This is what they try to ask. Specific humidity mass of water vapor in grams contained in kilogram of air. Vapor air can hold depends on the temperature. Higher the temperature, dryness increases, it can hold more. Relative humidity, it is the ratio of absolute humidity to humidity capacity. For example, usually in a particular air mass, 100% can be there, but actually only 52% is there. I call it to be 52 by 100, it is 52%. Let me take another case. In a particular air mass, only 50 can be held and there is 49. So can I say here, even though it is 52, the humidity capacity, that is air, what it can hold is 100. So you need to fill 48 to become saturation. Here air can hold only 50 and you have only 1. So if you add 1, this becomes saturated. So we call relative humidity, that is at a significant temperature or at a specific temperature. For example, 10 degrees Celsius. Water can hold 50, but now it is holding 49. So this is what I say, 49 by 50 is relative humidity. 20 degrees Celsius, water can hold 100, but it is holding 49. Relative humidity has reduced. It is cooling 49. If I further cool it, let us say 9 degrees Celsius, this will become 48. Let me say you have 48 is the capacity, but the moisture that is present is 49. So now what happens? The 1 will fall down. I'll just explain this again. See guys, at 9 degree, usually the capacity is 45. At 10 degree, the capacity is 50. Okay, 5 per degree, let us take 5% there. Now, some air mass is at 48. Now you are cooling that air mass. Let me say I made it 9 degree. The air mass became 9. At 9, how much can it hold? It can hold only 45. But how much is it holding? 48. Can I say 48 is more? Can I say this became heavy? Heavy means rainfall will happen. Do you understand? This is the reason if you cool the air, once it is at 30 degrees Celsius, it can hold say 100. But the air mass usually has 60 degree or 60%. Fine. Let me say 25 degrees Celsius, it can hold 80. 20 degrees Celsius, it can hold 60. So it's almost same. 15 degrees Celsius, it can hold 40. So once the clouds start moving above, it becomes cool. If it becomes cool, the capacity which it can hold reduces. So 60 minus 40, 20, this 20 units will come down. Right? Now what happens? You have 15 degree, 40 can hold, even cloud has 40. Now you further cool it to 10 degree. So what happens? At 10 degree, the cloud can hold 35 or let me say 30. But how much does it has? It has 40, the difference will again fall. So as the clouds move above, rainfall will be more. Then let us take the concept of clouds. Let us see what exactly are these clouds and how exactly can we classify them. When I talk about cloud types, the first important thing is from the sea level till 13 kilometers you may have clouds. Usually flights will move above 13 kilometers to avoid these clouds. Based on the altitude and shape, they are given different names. If you actually have horizontally developed clouds, we call it stratiform or layered. Can you see this? It is horizontally developed. Now, can you see this? Horizontally developed. If it is puffy, cotton shaped, vertically developed, can you see vertically developed? I call it to be cumuliform or cumulus clouds. Vertical, cumulus. Horizontal, stratus. If it is hair or smoke like structure, can you see this? We call it cirrus. And usually it is present at great heights. So usually ice will be present in this. Greater heights, ice will be present because water can become ice. On the basis of altitude, you can call low, middle and high. And vertically developed from low to middle or middle to high. First, low clouds. First see this, then I'll help you how to remember. See, you have stratus means what? Horizontal. Cumulus means what? Vertically developed. If you have something which is horizontally developed and vertically developed, you call it stratocumulus. Can you see this? You have horizontally developed throughout, but you have also the puffy structures being present. Then let me take nimbostratus. Nimbo means black color. Before rainfall, usually clouds become black. Black color. Stratus means horizontal. So this is also called as nimbostratus. Continuous rain or snow is usually seen. Nimbus, any cloud from which rain is falling, will be usually dark grey in color. Then you have cumulus, puffy shape. Cumulus, vertical development. This cumulus, if it is having black color at the bottom, we usually call it cumulonimbus. From side it looks white color, at the bottom it looks black color. Because it is at the bottom, they give heavy rainfall. And you have to remember guys, vertical clouds will give rainfall only till here. Horizontal will give to major area. This is the reason some people say, you are staying in one area, there was rainfall. Far off, say 5 kilometers away, there was no rainfall at all. The reason for this is cumulus clouds will be there. If stratus clouds is there, more area will be there. But less rainfall in more area is stratus, more rainfall in less area is cumulus. And remember, whenever it is vertically developed, cumulonimbus, thunderstorms are usually associated with cumulonimbus clouds. This is very, very important. Basic question, lightning, can you see? Lightning is usually associated with cumulonimbus clouds. Stratus, I have already told you, it is vertical. So what are the different types that you saw? First, you can say stratus. You have cumulus, correct? Combine these two to form stratocumulus, correct? 3. Then, do you have nimbus being added? Can I say nimbostratus, cumulonimbus? 5 types are done. Then alto. For medium, usually alto is used. You have altocumulus and you have altostratus. Can you see this? Altostratus, can you see? Usually cyclones, you see altostratus. Mid-latitude or mid-level clouds are associated with alto. Very, very important. Then you have cirrus. First, high latitude or high altitude, you usually see cirrus. So first, you have cirrus. I will add cumulus to it. Cirrocumulus. I will add stratus to it. Cirrostratus. Ice particles are present. Cirrostratus, cirrocumulus. And cirrostratus is associated with this particular type of sky. That is called as solar or lunar halo. What is it? Solar or lunar halo. What is it? Cirrostratus. Cumulus, can you see? Usually mackerel fish is like this. On the mackerel fish, these shapes are usually seen. We call it mackerel sky. See guys, cirrus, high cloud, alto, middle, cirrus, cirrocumulus, cirrostratus, altocumulus, altostratus. There is nothing called as alto, altocumulus, altostratus. Cumulostratus, cumulonimbus, cumulus, stratus, nimbostratus. Can you see 5, 3 and 2? Total 10 type of clouds are usually seen. Very, very important, and please try to remember it. Rainfall. Usually, I told you, you have convectional rainfall, and as it raises vertically, cumulonimbus clouds are usually seen. Even whenever it raises, cold front cumulonimbus clouds will be seen. Orographic, whenever you have mountain, orographic. Can you see here? Winds are raising above, and can you see winds are coming down? Raising means water will become ice. Coming down means ice will become water. If water becomes ice, rainfall will be there. If ice becomes water, no rainfall. So, this side, windward, usually receives more rainfall. This side is called as leeward, doesn't receive much rainfall. Cyclonic, along the fronts, whatever rainfall you see is called as cyclonic rainfall. If you have a cloud attached to the ground surface, you call it fog. Snow, if the water vapor condenses to such an extent that it falls as droplets, we call it snow. Sleet, mixture of snow and rain. Whenever it comes, we call it sleet. Hail, you might have seen hailstorms, right? This happens whenever the cloud goes so quickly in summer that some areas of the clouds, they usually observe rapid movement. And what happens when you have a big cloud like this, the water droplet or ice particles, whichever is at the top, when it is falling down, it usually tries to absorb other waters. And this increases in size as well. They gain size when they are falling. Can you understand? Water droplets are there, when they are coming, they keep adding and they come down. Rime, not in tropical regions, usually in polar regions you see. So they are attached to the leaves, right? These are some of the points that we need to understand as basics. Now in NCERT book, I'll show the chapter that you have to read and understand. There are just 5 pages. I want you to see this water in atmosphere where they talk about evaporation and condensation. Sublimation, if it moves directly from solid to gas, is called as sublimation. I have already told this. You have dew, frost, fog, mist, different types of clouds, precipitation, types of rainfall, convectional, orographic, cyclonic, world distribution of rainfall, how exactly it varies, we will be seeing. After this, you have the most important chapter, that is world climate and climate change. As I have told you, please read this with the basics that you have to see for biogeography. I'll be taking world climate and climate change, I'll be explaining Koyappan's scheme of classification, and then I will take biogeography, which is there in the last 2 chapters of this book. That will be biogeography. Is that fine? After this, you have to see 6th standard. Is that fine, guys? So, I hope this is clear. Take some time, revise this, and then go ahead. Thank you. Thanks for watching.